This is Precalculus Concept 33b, solving trig equations that have multiple angles. Again, we're going to start off with an example here. Our goal is to figure out all solutions between 0 and 2 pi such that the tangent of 3x equals 1. So the big difference here in this problem is instead of having an x in this spot, I actually have a 3x. And what we really want to think about this is that you want to basically think about solving for 3x first. And once you have solutions for 3x, then you can simply divide by 3 to get the solutions for x. But the restriction given here is on the value of x. So you want to think about the fact that when I solve for 3x, I'm actually going to have to solve between 0 and 6 pi. Right? Multiplying everything by 3, I get that new constraint. Alright, so I'm going to think about 3x as my answer initially and solve it just like I would with a simple trig equation. So hopefully you would think of 3x being an angle whose tangent is 1. One of those is pi over 4, and another one would be 5 pi over 4. Right? Again, a little unit circle picture might help. So I'll draw out a little circle here and think about the places where the tangent is 1. There should be a first quadrant answer and a third quadrant answer, right? Those are my solutions between 0 and 2 pi, but I need to go around the circle again. And so I have to think about, well, what if I went around the circle once and then added pi over 4? So that's going to end up being pi over 4 plus 2 pi. And then, as you imagine, I need to go around again because of the third trip around the circle. I would get pi over 4 plus 4 pi. Okay? And same thing. 5 pi over 4 is my first trip around the circle. 5 pi over 4 plus 2 pi is my second time around the circle. And then when I go around the circle a third time, I would get 5 pi over 4 plus 6 pi. Oops, sorry. Plus 4 pi. Right? And if I simplify those answers, here's what my solution to 3x would be. Pi over 4. Right? When I take pi over 4 and I add 2 pi is 8 pi over 4, so that gives me 9 pi over 4. And then 4 pi is going to be 16 pi over 4, so this one would be 17 pi over 4. Right, all three of those answers are still within the 0 to 6 pi window. And so, excuse me, I have those. Then I also have 5 pi over 4 and 5 pi over 4 plus 2 pi, which is going to be 13 pi over 4. And then I also have 5 pi over 4 plus 4 pi, which is going to be 21 pi over 4. Okay, so I actually end up with 6 answers. If you think about it visually, I've got the 2 answers in my first trip around the circle, and then I also have the angle there that's going to be second time around, and then that also the second time around, and then you're going to do another trip around the circle and pick up 2 more solutions. You're basically going around the circle 3 complete times and giving all the angles whose tangent is 1. Alright, so those are my 6 solutions, but notice that those are all the solutions to 3x and not what the goal of the problem is, which is what are the solutions for x. So good news, the last step's pretty easy. You just have to go through and divide everything by 3. So I'm going to have pi over 12. I'm going to have 3 pi over 4 for that second answer. I'm going to have 17 pi over 12. I'm going to have 5 pi over 12. 13 pi over 12, and then my last one will be 21 divided by 3 is going to be 7 pi over 4. Right? And those are my solutions. Notice that the final answers here all are going to be numbers between 0 and 2 pi because now I'm talking about the original constraint between 0 and 2 pi. And if you want to check a few of those, it might be a good idea, but all of those will satisfy the equation. As you might imagine, if you had tangent of 2x, you'd only have to go around the circle twice. If you had tangent of 4x, you'd probably have to go, or you would have to go around the circle 4 times. All right, let's look at one more example. This time I'm going to do a multiple of the angle that's going to be x over 2. So this time I'm going to think about my constraint for x over 2 being half of my original constraint. And so really when I get to the first solve, I only have to think about angles between 0 and pi. I'm going to think of x over 2 as my answer initially, and think about the angles whose sine is 3/2. If I think about a little picture here, it's going to be these two angles. I don't have to go around the circle a second time because my constraint says really I only have to look halfway around the circle. And so those are going to be pi over 3 and 2 pi over 3. Okay, those are the solutions to x over 2. If I wanted the solutions for x, I'm going to have to multiply everything by 2. So a final answer would be 2 pi over 3 and 4 pi over 3. Oops. Alright, this is a you try. Think about all answers in this window where the sine of 2x equals negative 1/2. Think that over and give your answers. Okay, hopefully you were initially thinking about the solutions for 2x. So there are angles whose sine is negative 1/2, and those would be 7 pi over 6 and 11 pi over 6. But because it's 2x, I have to go around the circle twice, and so I also need to add 2 pi to each of those to get the second answer. Okay, and that's where the 4 answers I came up with initially come from. And then when I solve for x, I go through and I divide all of those by 2. So those are the 4 solutions to this problem. These take a little practice for sure, but they all kind of start to resemble each other. Once you catch on, you just have to kind of think about the number of solutions to expect, and that will depend on what multiple of the angle that you have.